I got it right.
Question. How many groups think? Did you guys even talk in groups? You better have. How many groups?
I tried.
Were able to do something for the first one?
I attempted.
I didn't finish.
For number one?
I'm so proud.
For all two of them.
There's a peanut.
Thank you.
I tried one.
I don't think she had something, which means this whole group should have something, right?
No, I literally went like this. How you guys call this?
I was listening. Yes, because
All right.
we're focused on our own thing and we can't hear anything because you're just moving.
Ethan, how do you do this one?
I don't know.
Okay, why is the phone out?
I'm looking at it. The phone photos.
Okay. But you don't know, you don't have one, anything? Who else? Kelly, what do you think? A way to start?
I don't have it.
You don't know? I'm just trying to look for ideas. Anybody,
Oh.
anybody try anything? Did anybody say, you, Brandon, what do you think?
I don't know.
Would you be 1 plus e to the x?
That's what I would have thought, right? Okay. So what if u is 1 plus e to the x? Dilemma. Dilemma. Go ahead. Important Caroline next time. Important Ian, Emily, whoever else will do that. Okay. Question. If you have a u.
Thank you.
Kyle, is that the u you chose?
Yeah.
Me too. Okay. What do you have to do next? Maybe solve, but hold on. Let's just find the u. What do we got?
dx. Now we find it.
Solve for
Okay, so what happens when we do plug in?
You have it.
Now, can we take an integral right as it is? No. Kyle, hold on. Good job. The rest of you guys, look. What can we do?
Gotta solve for e to the x.
Oh, it's how it's
It's crazy integration.
Whoa, whoa, whoa.
Make it more appropriate. It's crazy integration.
Integration on track.
Yep.
Now you plug in u minus 1.
Now, whoa.
This is where I got.
Wait, now what?
Now you can multiply u times u minus 1.
Yeah, I factored the u in.
No, can you bring it up to negative?
I can't make it u squared minus u. I can make it e to the negative 1 times u minus 1 to the negative 1, but that's a product. How am I gonna?
So it factored u in.
But you can't distribute.
Make it a v.
But you can't distribute.
You could do 1 over u squared minus u, which would be u squared minus u to the negative 1, but how do you integrate that?
Is this complete the square?
No.
This
This is pre-calc.
Free cow. Oh, Ellen.
Something called partial fraction decomposition. Partial fraction decomposition. Off to the side. This could have been a common denominator from something. Now, we're actually going to have this come up in a section a little bit later on. This is one of the new BC things. I think we saw it once, maybe in EV.
It's free now again.
Somebody over u plus somebody over u minus 1. These could have joined together to get this one by partial fraction decomposition. Does anybody remember how to solve for a and b? Just think mathematically. What do you want to get rid of? Yeah, the denominators. How do you get rid of all of them in one shot?
Multiply by the second.
Multiply by the common, right? What happens when I distribute in there? What do you got left?
You can.
The u cancels and you have a times the u minus 1. What happens when I multiply into there?
You minus 1.
Do you remember now?
Oh, I'm sorry.
Oh my goodness. That's not even. How did you do that?
Pause. Think. I put the u terms together. Okay, u plus bu is a plus bu. Just think, factor out the u. I put the non-u term on its own. And why did I write a 0u on the left-hand side? There is. Not u equal to 0. What am I going to set equal to 0? A plus b must be 0, and a must be 1.
Which means B must be negative.
Wait, wouldn't it have to be positive?
Wait,
Negative
A
one?
is a negative 1, right? Wait. Oh.
Yeah, negative one.
So what is?
B equals 1.
Mhm.
And B equals
So if a equals negative 1, then what does b equal?
1.
So I can say this integral is the same thing as a is over who, u?
1 equals negative.
Oh, it's a negative.
Whew! It was log all along, natural log to be precise.
Wait. We didn't finish though, right?
I know, I just need more room.
Please don't tell me there's only like 3 whole questions.
This actually isn't even a section. I was just trying to show you that this one, even though it looks impossible, is not going to be able to be solved by parts. It's actually solved by pre-cal, partial fraction decomposition, and integration on crack.
Not gonna work.
Does it follow that I am allowed to legally go there for my answer? I could say v is u minus 1. What would dv be? If v is u minus 1, dv would just be 1 du. I'm fine. I don't need any other dv for that. So I can go straight to an ln. Or think of it, what would be the derivative ln of u minus 1? 1 over u minus 1 times 1. So we're okay. If it was a 2u, then I'd have to have a 1/2 in front. We might have to do another substitution. But since it wasn't, I'm able to stop there, and then I end up with negative ln of, who was u? 1 plus
e to the x plus ln of
e to the x plus 1 minus 1, yeah, just e to the
Or
x.
is this because e to the x is the b minus 1?
Wouldn't that just be X?
Because ln and e can cancel, right? And also, e to the x is always positive, true? So then I could go ahead and just say, forget the absolute value, it's okay, e to the x is always positive, and ln of e cancels out. Over here, e to the x always positive, plus 1 always positive, so I just put negative ln of 1 plus e to the x, plus c. Or if they wanted to be super snazzy, couldn't they make that? Well, if there was an ln, yeah, but I took the ln out. They could have made it multiplication, well, division. This guy would be on top and that guy would be on bottom. They could have done that. Or they could rewrite this as ln of 1 over 1 plus e to the x. They could use properties to make this look a lot of different ways. They could have made this,
Couldn't you multiply them?
these are all the ors.
No?
That's right, that's right, that's right. Or they could have done ln of e to the x over 1 plus e to the x. Oh, but you don't need absolute value, that's always positive. It would have been division because of the negative.
Not me.
There you go. Any of those would have been right. What kind?
Like I'm looking at the second choice, and when you derive it, wouldn't that just be 1 plus e
Deriving what?
Well, dirt off.
No, it'd be 1 over u times u prime. Plus 1. So it'd be 1 over 1 plus e to the x times e to the x, and then plus x, and then the negative. Right? 1 over u times u prime. 1 over 1 over u.
So wouldn't that be in the denominator top when you derive?
When you derive ln, it's 1 over u times u prime. You said the second one, right?
Okay, maybe.
Okay.
I meant third one. Sorry.
Oh, good. Sorry.
So then that'd be 1 over u, which would be 1 plus e to the x times u prime e to the x plus 1.
But how would that go back?
Well, it might not be the same form as the other. Plus 1. If I went to the partial fractions, that'd be, I can make this 1 over 1 over. I feel like you'd multiply top and bottom by this, top and bottom, on both. Or you could factor it out. I mean, our objective doesn't really make sure it goes back, but, I mean, it should, but these are all by pre-cal equivalent. And as soon as we change the form of the derivative will change as well, which is why it's sometimes hard to make it match. But you could theoretically factor out a 1 plus e to the x. You would have an e to the x plus 1 over 1 plus e to the x. I'm thinking of the partial fraction idea. You could go ahead and rewrite this one as like a 1 over e to the x. I mean, I could make these into fractions, I just, right now, my objective is not to make it match, so I'm going to go ahead and just say, according to pre-cal, yes, that matches as far as being equivalent. But you could play around with it and see if you can make it match. Wait, there was one more tricky one, right?
Can we unpack this on ourselves?
Okay.
I don't understand.
I think I can do this one.
You gotta choose who U is.
I'm
And
guessing.
guys, on the last one,
Is it?
almost all of us would have chosen the right U. It's just where do you go from there? So let me give you a whole 60 seconds. Let me give you a whole 60 seconds. So you're gonna go down a rabbit hole like it's gonna simplify. Because the cotangent's gonna be cyclic, like so it's gonna cycle. And the ln of sine is gonna go forever too.
Where did mine got it?
Maybe.
I think I got it.
Maybe. Is there like a U and a V?
Oh, that's not
Who's U?
I said ln of sine x and then the sine of x is. What?
That's the U.
But you're close.
What size is it?
Well,
And you can't
I
split
think
the
it's
plus
a power rule. So I think you put cotangent to the power.
To the power of the cotangent.
Yeah, that's what.
What?
Did you guys look at that chart of integration rules? What's the integral of,
I don't have.
or the derivative of?
Oh no, it just says it's gonna power rule.
Oh, wait. I agree with what Brendan said, after all. But not the V part. But your U is right.
I changed it. I thought that it was.
Oh, that's. Do you make it U to the cotangent?
Oh wait, no.
So it's U to the x.
Because then you just got U.
The sides are canceled.
Oh, come on.
You just do
Yeah, you. Come on.
What's the derivative of ln of sine? Times?
And it canceled, yeah.
Oh, what do you know?
You can write rewrite code.
Yeah, that's what you're saying.
I'm sorry.
What was that?
Isn't it just U du after you plug in?
Yup.
You try to simplify it? Don't. There is no legal ln property that says if an entire ln is squared that we can do anything. It's only if the argument is squared. If sine was squared, we could bring down the 2. But since it's the entire thing squared, nope, you're stuck. But U was ln of sine of x. Any questions on this one? Does it make sense?
Yeah.
Okay, so far, have we needed any brand new techniques? Not really. That was,
First one.
the first one was really old techniques.
Yeah, Noah.
That was partial fractions from pre-cal. This one was just knowing your rules well enough. I mean, if you had chosen u as cotangent, negative cosecant squared, But if you choose u to be ln of sine, then keep going. Jason,
If you did do integration by parts, it could work.
what would you use as u?
The second part where it's minus the integral of that, you can add it to the other side so you get 2 times that, and then divide by the 2 and you get the same answer.
No, but you wouldn't get ln of sine of x to match again, would you?
Yeah, because the
Who'd you choose as u?
ln of sine of x, and then that turns into cotangent of x, and then if I use b as cotangent of x, that turns into ln of sine of x. It becomes the same thing.
Oh, I see. Yeah, that's true. I wasn't integrating cotangent in my head. I was just deriving the Nicely done. You guys will learn what he just said later. Use trig identities. This one might look impossible, but it's not. We're just going to work together on this one, unless you want a 30-second head start.
30 seconds.
Now guys, here's the struggle with 7-3. If we're starting something new to deal with impossible integrals, what we're starting with is some might look impossible, but they're not. So you can't just assume that any hard integral needs this new technique.
What are the...
It's not moving letters on the paper.
What is the double angle formula?
Sine 2x is 2 sine cosine. Cosine 2x is cosine squared minus sine squared, or 1 minus 2 sine squared, or 2 cosine squared minus 1.
So sine is 2 sine.
I know, but I know sine. It's just sine over cosine.
Wait, is it 2? Wait,
I
sine
know
is
it's squared. 2x.
Don't try to say it.
What?
You already had 30 seconds.
Didn't you say we don't have to do this?
I bet it's negative.
Yeah,
Yes, I am.
that helps.
Wait, what? Oh yeah, that is a rule. That's a rule. I'm gonna go different to see if that fits.
That's clever, Mr.
With a little bit of difference from that. It's closer.
You guys good? Why go to 1 minus secant squared from tangent squared? Pythagorean property? Because secant squared I can integrate, tangent squared I can't.
Do you have to like this?
You were thinking sine 2x squared over cosine.
No.
So this isn't the new method.
This is.
No, these are just ones that you might think are impossible, and so I want to remind you that just because it looks impossible doesn't mean it needs the new method. Yeah, I think.
So the 1/2 that you pulled out after you found du, that would only apply to secant?
Because that's the only place that I'm doing a u substitution.
Oh, okay.
If I had done u here, I could have plugged in du over 2 1/2, but then when I go to plug it, it'd be 1/2 times u, which would still be x.
Don't tell me this next one, but I can just.
So that would have worked. Corey's already on the next one. Am I giving it another 30
Can we
seconds?
solve for x and then plug in all the u's?
No.
I wouldn't.
There's an easier way.
No.
Complete the square. Nope, don't do that.
Don't do that.
Make u what you would think he naturally is.
You plug out, you take out the 6, gives you x plus 1, x plus 1 cancels, gives you 1 over 6. So there's 6 squared.
AKA, keep it inside, but Brendan, what he's saying is that u to be what's under the
I'm
square.
trying to work with my group.
Yeah, I know that. But like, I don't know if I'm just blanking right now.
Pull out a 6.
Yeah. But since it's on the bottom of the,
Oh, negative 1/2.
no, that's not what I was asking.
So it's on the
It's
bottom.
on the bottom of the fraction when you take it as you
Oh, no, just make u the, because you can make it to the negative 1/2 power later. Don't worry about it being in the bottom. Is this one of the easier ones?
Just back in order.
Double check. You guys agree?
No, 1/3?
Yes.
Don't attack Miss D like that.
Add 1, divide by 1/2, which means multiply by 2. You didn't even have to do like a splitting up and make 1 into like an arc. That would have been nasty anyway. It's more better. Okay, question. We just saw 4 different tricky integrals. Just because something is tricky does not mean it needs the new method, right? Just because something is tricky does not mean it needs the new method. Jason looked through, and I think the only one that could have been integration by parts would, well, the only one that would have even been useful to try would have been the second one. Okay, integration by parts. When do we need it?
No.
There's an example. And this is one where you might get stuck, and you should get stuck, because there's no other way to solve it without the new method. Why or what is different about this one?
Did the mic share the same now?
Okay. What's different about the trickiness of this one than the other?
There's no way to substitute or split it up. So
If u is x, du is 1, that would just be u and sine of u. That doesn't really help. If u was sine of x, du would be cosine of x. But then you get rid of one trig and then you get another trig, and
But
so
couldn't
you're
you,
still in
like-
trouble.
You probably can't.
No, go ahead.
But if you had, if u is sine of x, then x is sine inverse of u.
So you go ahead and
Oh,
rewrite
but then
it
you
to
have, oh, because then you can't cancel the cosine. Never mind. Yeah, perfect. Go! That's exactly what I was doing.
That's a good idea. It was doing something, and we have all U's, but that's not something that we can solve. So, integration by parts. Here we go. We go back to the product rule. All right, guys, focus on it. We go back to the product rule. My turn. My turn. Okay, we go back to the product rule. Kiddos, do you agree that in order to take the derivative of a u times v, we take my version, second v first plus first v second?
Okay.
So we do u v prime plus v u prime, right? Now, what if we were to throw in some integrals? Okay? So we have d dx of u v. Or maybe a better way of putting it, let's do it this way. We can say y is equal to u times v. So dy dx. Okay. What if I wanted to solve a differential equation? What would I do? Okay, multiply dx by both sides, so I have dy is equal to uv prime dx plus vu prime dx. I'm just distributing. So I could go ahead and integrate, right? Integral to both sides. But technically, if I take the integral of the right side, the sum property, couldn't I take the integral of both pieces? Good. On the left, wouldn't I have the integral of 1 dy is just y? So over here I have the integral of u times, now hold on, wait a minute. V prime dx. Who is v prime? dv dx. So what would be dv dx times dx?
Ooh, dv.
dv. And who's u prime? du dx. What's du dx times dx?
du.
Oh.
Oh.
Oh, wait a minute, and who's y?
Why is vu? Why is u?
Maybe this? And so integration by parts comes from basically taking a product rule, putting in a differential, solving the differential equation, and saying, well, I don't have either of those. True, but what can you do? You can solve for this one by subtracting the other one. You end up by just flipping the sides to make it look prettier. U dv is going to end up equaling u times v minus the integral of v du. Integration by parts is based on that formula right there. And what it allows you to do is to look at an integral. To look at an integral as having two different separate components, one of which came out of the derivative of an original, and one of which came out of the integral of a differential. You can look at one piece as having been integrated from, integrated from another, and you can look at the other piece as being derived from another. And so when we see this x times sine of x, we don't have to look at it as one complete whole. We can kind of say, wait a minute, I think this came out of a product rule where there were two separate pieces. Now, is this the entire product rule? No, there's no plus. But this could have come out of a product rule. And in order for us to think through how to use this formula, we're going to say, okay, let's look at this formula as having two pieces. Now, dx had to come from the derivative part, right? Does that make sense? Dx had to come from the derivative part. So who should go with dx as having come from or having been derived? I don't know. You guys pick something. What do you think? Okay, so let's say we did say the sine. Let's say we did say that the sine and the dx was all dv. Okay, well if that's dv, then what must the x have come from?
Du.
Or v? Okay, let's see if that helped. If that's a u and if that's a dv, we can say, okay, fine, by the rearrangement of the product rule, solving a differential equation, we could say, okay, u, x, wait, how would we plug in v? Okay, so we have to integrate. In order to get our u times v, we would need to say if this is dv, then guys, if that's dv, then what's the original? If this was the derivative, where did he come from? We have to integrate just sine of x dx. And what would be the integral of sine of x dx? Negative cosine of x. Minus, So first of all, you have to choose a dv that actually can be integrated, or else you couldn't possibly get that piece. But we could integrate sine. Okay, cool. But now we have an integral of, okay, who do we need? Who is v again?
No, it's negative cosine of
Good. Times, what's the derivative of u? 1 dx. I couldn't have solved that outright with u sub, but question, can I solve the integral of negative cosine?
Yeah.
Yes. Integration by parts, when done properly, will eventually guide you, maybe with maybe with repetitions or multiple iterations, should get you to an integral that you can solve. almost always, except for the exception that Jason was talking about earlier.
Misty, does it say negative cosine x times 1 dx?
Uh-huh. Because v was negative cosine, and the derivative of u is 1 dx.
Okay, thank you.
So, let's look and see what we had to do, and let's try to have it inform our strategy for using this formula down here below, okay? What ends up happening to the u, oh, my highlighter went away. What ends up happening to my u once I go into plugging in the formula? So whoever u is, whoever we choose, what ends up happening to him? It stays the same, easy, and what else? He gets derived. Would it be helpful if I chose u to be someone who derived to be more complicated? No, because then your integral just got more complicated. We want to choose u so that when you derive it, it becomes simpler. And what ends up happening to my dv? He has to be able to be integrated. If he can't be integrated, well then he cannot be chosen as dv. We have to switch the order. Yeah.
So if it was a division, you would use quotient rules or what? Or would you make it negative?
Theoretically, but the dilemma with quotient rule is it's not as easy as an addition that you can split up the anything.
So you would do it out as a negative.
You could try thinking of that. But with a quotient, you probably still want to think of it with integration by parts if it's, just make sure it's not one of those tricky ones that we talked about. Because there's a lot of quotients that can be rethought of in a different. Okay, so long story short, u is someone that derives to be simpler, v is someone that dv is something that can be integrated. Okay. Oh, I didn't end up using that page. Haha. So, guys, does this make sense? Integration by parts. I'm going to call it Lucky 7. Stand and Deliver called it Tic-Tac-Toe, but that was only one version. Just careful, Tic-Tac-Toe is not always helpful, I don't think. I'm going to call it Lucky 7. Stand and Deliver called one type of problem. Tic-Tac-Toe is called the tabular method.
Is this another form?
Yeah. I know, guys, sorry, grades are due on Friday, so I'm not...
Misty, how much do we get for lecture later?
I'm saying that each problem is worth a plus of. Does that make sense?
Yeah. It's really confusing, like, when it's not the review they're missing, because I can see when they're missing the review, but it's worse when, like, it's a random one.
Oh, like in the middle? Yeah. So kiddos, can you go ahead and try to solve
Yes.
the example below? Nice thing is it's super similar to the one that we just did. But I am going to go ahead and show you what I mean by Lucky 7, if that's okay. Lucky 7 says, off to the side, think about the integral as having a u and as having a dv. And from the u, derive to find du, integrate to find v. And then the formula says u times v minus v du. Ooh. 7. U times v minus the integral of v to u. Doesn't mean you have to do it that way. There's the tabular method, which I only think is sometimes helpful. And there's also just the writing it out way with the formula and plugging in. What do you guys think is u? So if u is x, then what's dv? This is where being able to do u sub with mental math comes in very handy, and maybe why we did work really hard trying to develop mental math with u sub. Because right now, just to set up the problem, the du, hopefully that's not too bad. Sometimes you might want to do work off to the side, but what's the derivative of x? Yeah. 1, and then think du dx, move to the other side, so 1 dx. But to integrate or I should say to find v, you do have to integrate. Ah, stink, that's a sign of u, isn't it?
So negative
Could you go off to the side and now, plus c?
No.
No.
Well, where we plug it in, it's gonna be in an integral, which is also gonna have its own plus c, so we actually don't really need to worry about it. Because when we plug in the v, yes, it's gonna be there, but the plus c is gonna combine with the plus c, it's gonna come out of the integral. We're actually okay. We're actually okay not to put the plus c. But you would have had to think about, you said du is equal to 3 dx and then divide to the other side. Now, when we go to solve, left at 7, I can say my original integral is equal to u times v, negative 1/3 x cosine of 3x, minus the integral, wait a minute, can I pull out the negative 1/3? So plus 1/3 times the integral, cosine of 3x dx, which we can find by, oh hey, it's just cosine of u, but wouldn't that be another 1/3 sine of u? There's the plus c from that final integral. We have the original. Could you rewrite it? I'm sure. But the question is, did we solve it? Yes. Now tomorrow we get to have some more excitement, because we didn't get very far in the tricky examples with the new methods. So good, hey, I was terrible until you get stuck and then tomorrow we'll talk about arguments. Bye guys.
You can ask, do you have